All right, 3 minutes of lecture. So last time we were talking about an introduction to recursion. We talked about how the most basic example of this was you're standing in a line, you're trying to figure out your position in line. You're asking the person in front of you how many people are in front of you. When they return that information to you, you add 1 to it and know that that's how many people are in front of you. So that's exactly what we have here. And it's worth noting that every iteration of this process has the exact same structure. The person in front of you implements the exact same function that you did to figure out how many people are in front of them. And the person in front of them is implementing the exact same function that you did and the person in front of you did, and etc. So that means we can take all of this complicated logic and squash it down into just a few lines of what happens in the general case, and then over and over and over, we will implement that general case to be able to answer a more complicated question. So recursion in its basic definition is just a method that calls itself, function that calls itself, whatever you want to use there. We talked about the components of a recursive algorithm being a base case, meaning what happens when the person can answer the question. There are 0 people in front of me. That is the base case of that problem. So we don't need to ask the person in front of us if we are the first in line. The general case is broken here because we can directly answer the question. Then we have the recursive case. That is the generic case, what everyone else except for the person in the front of the line has to do. So we don't know how many people are in front of us, so we can rephrase it in terms of a smaller or simpler question. However many people are in front of the person in front of me is 1 fewer than the people in front of me. That is the smaller or simpler question, or the way to think about that question. And eventually you can recurse that question and ask it over and over and over and over and over again until someone has an answer. So what we're going to dive into starting on Monday is a significant number of examples of this that we are going to code in class. Let's at least get you started thinking about it for the weekend. So I'm actually not going to do this because I'm making it. You can imagine writing this, what we've talked about, as a function, number of people in front. But I'm going to dive right into some other examples. So the first example that I like to do is a factorial. So if we've written a factorial method in the past, you've probably done it iteratively, right? You have some kind of loop that goes through and calculates a factorial. So if I want to know what 5 factorial is, I say, well, 5 factorial is from 5 down to 1, the current value, the product times the current value, decrement the current value. Product times the current value, decrement the value. Right, back and forth until we get down to 1, and then product is the final value of that factorial. But of course, iteration and recursion are actually equivalent to each other. Anytime you can set up a problem iteratively, you can also set it up recursively. Sometimes that leads to more work. Sometimes that leads to less work. So knowing when you can implement something recursively and save yourself some time and effort, that is very useful. So my challenge to you over the weekend is to think about, in factorial, what is the base case and what is the recursive case? Can you think of how to phrase the factorial kind of like a bunch of people in line? If my task is to calculate 5 factorial, I could pass along and say something like, I know that 5 factorial is 5 times 4 factorial. What is 4 factorial? I have no clue. I'm going to pass that information along to the person in front of me in line. We're all bored waiting for this best event in the history of ever, right? So we might as well calculate some factorials while we're doing it. So if I'm trying to calculate 5 factorial, I'll ask the person in front of me, what is 4 factorial? You can tell me the answer to what 4 factorial is. I'll just multiply that by 5 and have the answer. The person in front of me now says, 4 factorial. Well, I don't know what that is, but I know it's 4 times 3 factorial. I'm going to ask the person in front of me, what is 3 factorial? When they return an answer to me of what 3 factorial is, I'll multiply it by 4 and I'll have an answer. So take a stab at this over the weekend. See if you can implement a recursive factorial that is a function that calls itself. And we'll implement it in class on Monday. I have office hours starting now. Please remember to bring me your exam before our meeting. Thank you. Great.